All right. I hope all is well. Hope you're doing all right. So I'm going to go ahead and address your questions. And sorry about the delay, told you I haven't been feeling the greatest. And then also my kids, I guess you can hear my voice too, but also my kids caught something and yeah, it's been tough. Kind of threw me off. So let's look at it. Derivatives via limit process and conditions would be necessary to use. Nope. As long as you know the regular differentiation process, it doesn't matter which one you use. So it doesn't matter. One's the long way, one's the short way. And that's all there is to it. Yep, I'm trying to see if I can find this thing. So, yep, that's all there is to that. That's the first question. It doesn't matter which one you use. And then, like I said, I can't think of a condition in which you would be forced to use the long process versus just using your differentiation rules. So, yeah, they're just showing you the background behind it. And sometimes they show you the long way of a process to emphasize why you should use or why you should appreciate the short way and the rules that they came up with and how they came up with all the good stuff like that. So, all right, the location of the negative signs. So, they had problem with 2.2, number 10. Does the location placement of the negative sign matter? No. As long normally, so when you look at the location of your negative in your answer, see if I can get to the bottom of this page. All right. So when you get to the location, so if you have negative one half, or like here, all of these equal the same thing. Except when it comes to putting your final answer in, normally this one is the one that's not accepted. Notational wise, either you put the negative up top or you put the negative out front. And even though the negative in the bottom, as far as the fraction is concerned, is still the same answer, normally that's not used as your answer. These are the two that would be acceptable as an answer. So looking at what you have here, you have negative 3 over 2x. Yeah, those two are the same thing. It says that you had problems with that one. Now, so you can email me back. Did it mark it wrong? So I see that you have versus putting it out front. Yeah. So both of these are the same answer, whether the negative is up top with the 3 or out front of the fraction. So are you saying that it marked it wrong because of the negative, or what was the problem? I know you said you had a problem with it and then you showed me the negative signs. The negative signs in your case wouldn't matter. But if you marked it wrong, let me check something real quick. That's 2.2, number 10. Uh, 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 um, yeah, no, that should be the answer. So, um, yeah, check it out. Let me know if it was something else that could have been it. Oh, as a matter of fact, let me pull yours up. No. Okay, you got it right. So no, yeah. So if you had any issues with it, it wasn't the negative sign. So I see you got it right with the answer, and you put the negative out front. But yeah, whatever your issues were, it wasn't because of the negative. Yep. All right. Let's see the next question. 2.4, number 10. All right, 2.4, number 10. So, we talked about it before. The problem I have, my phone would go out. Come on, come on. All right. All right. So, another way of looking at this. Excuse me, is that square root is 1/2 to the, as far as the power is concerned. Um, so we're gonna have to use our quotient rule. And how do I want to write it? All right. Excuse me. All right. So if I'm gonna use the quotient rule, derivative of u over v. So I'm gonna do v u prime minus u v prime over v squared. And my u, of course, is gonna be in this case 2x. V is gonna be, as a matter of fact, I'm gonna do that down here. So then derivative of 2x is 2. Derivative of x squared plus 6, you're going to bring the 1/2 down and subtract 1 from the 1/2. And then you're going to take the derivative of the inside. So it's just going to be 2x and multiply that. Then the 1/2 times the 2 will cancel. Leaving with just x times x squared plus 6 to negative 1/2. And that is it for that. So let's go ahead and plug it into the formula. Quotient rule formula. So v is x squared plus 6 to 1/2 times u, which is 2x. Yep, u prime, excuse me, which is 2 v times u prime. And then minus, yeah, I think, let's make sure I did right formula right. Sorry. And then u, which is 2x times v prime, which is x. Now x squared plus 6 raised to the negative 1/2 all over v squared, which is x squared plus 6x raised to the 1/2 squared. And so this is D prime, D prime. Let me see D squared. All right, so let's simplify. So that's just 2 times x squared plus 6 to the 1/2 minus 2x squared times x squared plus 6 to the negative 1/2. And then here, 1/2 raised to the power of 2, you just multiply your exponents. So it's going to be x squared plus 6. All right, so we want to simplify this. So if I were to multiply top and bottom, so if I would factor out, okay, let's see, if I would factor out x squared plus 6 negative 1/2. How about I do this? That'll be easier if I multiply top and bottom. So I want to simplify this as much as possible. So what I'm going to do is multiply top and bottom by x squared plus 6 to the 1/2. All right. So the reason why I did this, don't forget your exponent rules. If I have x times x, that's going to be x squared because you're adding your exponents. If I have x 1/2 times x to the 1/2, that's going to be x to the first power, which is just x, because 1/2 plus 1/2 is 1. That's x. Same thing as if I have x x to the negative third times x to the negative third. Let's go positive. X to the negative third times x to the third, adding your exponents, so it's going to be x to the 0 power. Anything to the 0 power is 1. So these are exponential rules that I'm about to implement. That's why I went, or I'm going the route that I'm going. So let me erase this and go back up. All right. So I'm going to multiply this x squared plus 6 to the 1/2 to both pieces here. And of course, this multiplies to this. All right. So 1/2 plus 1/2, we just mentioned, is 1. So it's going to be 2 times x squared plus 6 to the first power, which is just that. I'll leave that right there. And in here, x squared plus 6 to the negative 1/2 plus x squared plus 6 times x squared plus 6 to the positive 1/2. This is going to be x squared plus 6 to the 0 power. Down here, x squared plus 6 times x squared plus 6 to the 1/2. Now the exponent here is 1, if you were to look at it that way. So you're talking about, I'll just write it for note purposes, 1 plus 1/2 for your exponent. All right. So now we're looking at 2x squared plus 6 minus 2x squared, because anything to 0 power is just 1. So I'll write it like this just for note. So it'll be 2x squared times 1. And then this would be 2 over 2 plus 1 over 2, which is 3 over 2 for your exponent. All right, so keep going. We can distribute. That's 2x squared plus 12. Said 12. My fingers didn't want to do it. Minus 2x squared, x squared plus 6, 3 half. And now 2x squared minus 2x squared. That's pretty good. Right there. Cancels. Leave me with 12 over x squared plus 6 raised to the 3 halves power. And that's your answer. All right. That's all right. Not let me know. All right, next one, implicit differentiation. I got the answer, but I'm confused on how the product rule has been executed. Is the chain rule not used here? Let me look at it. All right, so yes, the chain rule and the product rule is used. Let's see if I can look at it. Well, first thing you could do if you want to simplify, you can get rid of the 5. 5 both sides by 5. If you just want to get rid of it, because it's all multiplication. Just one less number to deal with, but you don't have to. Just a constant. All right. So the product rule, is u times v plus v prime times u times v prime plus v times u prime. Yeah. So sorry about that. Let me get over what I got going on. All right, so here's where the chain rule comes into play. So that's going to be 5 or negative 5 sine 5x. And then v prime is going to be 2 sine 2y dy dx. This is always whenever you take a derivative of an expression with respect to another variable, you always have that, that piece left over. The variable we're looking at is y. We're taking it with respect to x, so that dy dx is still going to be there somewhere. And if you don't use dy dx, then you use y prime. Represent dy dx. All right. So use cosine 5x times b prime, which is 2 sine 2y dy dx. Well, why extra 2y? But I'm mixing up things. I got cosine, sine, Okay, I got U right here. Oh, I didn't put a cosine on here. I'll put some. I know there's something like this. So it should be like cosine here. All right, now I'm at point. And then V sine 2y. And then U prime is -5 sine 5x. It's not bad. -5 sine 5x sine 2y 5 cosine 5x cosine 2y dy dx. Okay, just make sure I got my stuff right. Okay, so simplifying. Just bring that 2 out front. Oh yeah, the right side, the derivative of 1 is just 0. Any constant, just 0. All right, so we need to now solve for dy dx. I'm gonna add 5 sine both sides. I'm just gonna write that. You add over is there, so you cancel out of here. And then divide both sides by 2 cosine 5x cosine 2y. So that cancels out over here. And then we have dy dx equal to 5 sine 2y sine 5x over 2 cosine 5x cosine 2y. All right, so let me make sure now that's the coincides with the answer. Okay, so now we can simplify it a little further just by using our trig relationships, trig identities. So if I do sine 5x over cosine, because all this is multiplication. And when you have all multiplication, you can move the terms around in the numerator and denominator accordingly. It's all multiplication. So that's 5/2. Sine 5x over cosine 5x is tan 5x. And then sine 2y over cosine 2y is just tan 2y. And that's it, most simplified. All right. Let's look at the next one. Just want to see the actual next one. All right, so that's number 6. Once again, implicit differentiation. All right, so we have to implicitly derive this as well. So we have, we take the derivative of both sides with respect to x. And I didn't write this like this last time, but it's basically what we did. We went to the derivative of both sides. I'm gonna bring down the 6 as my power. Everything stays the same. Subtract 1 from my exponent. That's 5. Now I gotta take the derivative of everything on the inside. All right. So derivative of sine is going to be cosine, but you got that pi in there, so that's pi. Don't want to write it like that. I just write it in one. So it's going to be cosine pi x times pi plus, and then derivative of cosine is negative, so it's going to be negative sine, not put x, pi, negative sine pi y times pi times dy dx. And equal to 0. So the derivative of 48 is 0. All right. Okay, all right. So I need to get to this dy dx. So notice this part is being multiplied to this. So in order for me to get to what's on the inside of this bracket, I need to divide both sides by 6 sine pi x plus cosine pi y to the 5th power divided by the same thing over here. So this cancels, but this is just 0. So I'm trying to, all right. So what you're left with is cosine pi x. Well, it should be pi cosine pi x. Pi cosine pi x minus pi sine pi y times dy dx equals 0. All right, so we should be okay with that. Now we go to solve for dy dx. Subtract pi cosine pi x. That's a here. Left with negative pi sine pi y dy dx. Pi cosine pi x. Now divide negative pi sine pi y. All right, so then I have a negative over here. Yeah, that should be a -2. I'll just negative off right here. When I subtract it, it's be a negative. All right, so now negative pi cancels. Of course, this cancels. And dy dx is equal to cosine pi x over sine pi y. And that should be an answer. You can see it not going over here. It's sine pi y. Yep, and that's it. All right, check it out. Let me know if you have any questions on that. We have one more question. Don't know when to use trig functions in the chain rule. Oh, okay. So whenever you have something in your trig, something that your trig function is being applied to other than just the variable, you have to use that chain rule. So if I had cosine x, if I have cosine x, that's just equal to negative sine x. And really, you're actually doing the chain rule, it's just that you don't, it's just not emphasized because the only number that's sitting in front of x is 1. And so it's not a big deal. Because 1 times anything is itself. But let's say if I had cosine of 2x, then the derivative of cosine, the cosine part is going to be negative sine 2x. So the 2x is still there, it still applies to the same. But then you have to multiply that times the derivative of whatever is on the inside of here. See, the derivative of cosine, the derivative of x is just 1. So really, like I say, you just multiply this times 1. That's why you don't have to really recognize the chain rule. But the derivative of 2x is 2. So that means the answer here is going to be negative 2 sine 2x. So once again, whenever you have to multiply, whenever your trig function is being applied to something other than the variable, if there's anything extra inside this parentheses other than the variable, then you have to apply the chain rule. If it's x squared, if it's, x plus 5, x plus 5 is still give you 1, so it's not a big deal. But you see what I mean. If the derivative on the inside does not result in 1, then it has to be applied. You have to use it. All right. So hopefully that's good. Let me know if you have any more questions. Like I said, sorry for the delay, but series of illnesses ran through my home. So apologize for that. All right, let me know if you have any questions. Take care.